Hello students, we are starting a series of class 10th chemistry. In this video, we will cover chemical equilibrium chapter, only SLOs of this chapter. The detail about each and every topic will be included in the next video. So dear students, this is lecture number 1, which is a discussion on SLOs of chemical equilibrium. So in the first SLO, we will learn about the definition of chemical equilibrium in terms of reversible reaction. Then we'll move towards the forward and backward reaction and description related to microscopic characteristics for each of them. Then we will define law of mass action. In the next SLO, we will derive an expression for the equilibrium constant and its units. Then we will move towards the necessary conditions for equilibrium and a way to recognize that chemical equilibrium has been established. Then we will move to the equilibrium constant expression of a reaction. So students, let us first learn about reversible and irreversible changes. Then we will define chemical equilibrium in terms of reversible reaction or reversible changes. In the picture, so there are 6 pictures which you are watching on the screen. In the first picture and the fourth picture, let us compare these two first. In the first picture, ice cream has been melted, and in the fourth picture, wood is burning. Out of these reactions, can you tell me which one is the reversible and which one is irreversible? Of course, the reaction which is in the fourth picture is irreversible. So similar is the situation with next pictures also. The first 3 pictures contain the phenomena which are reversible, and the last 3 pictures showing the phenomena which are irreversible. So for the reversible reactions, there is a possibility that they can proceed in the both directions. The both directions mean they can move in the forward direction as well as in the backward direction. While there is no such situation exist for irreversible reactions. As we have mentioned that for the reversible reactions they proceed in the both direction, that is reactant can convert into the product and product can convert back to the reactant. And when these reactions are taking place, a state reach where no more reactant will convert into product unless and until we remove these product from the system. And this is the stage when we see that there is a balance between amount of reactant and amount of product. This is called as the chemical equilibrium. So students, as you have learned about the chemical equilibrium as well as the reversible reaction, the next SLO of this chapter is the definition of law of mass action. This law states that rate of a chemical reaction, that is the speed of a chemical reaction, is directly proportional to the product of the reactant concentration values. That is when A of A reacts with B of B and gives us C of C and D of D. The ratio between C, D and AB is called as the Kc. So the next SLO is the derivation of an expression for the equilibrium constant and its units. First of all, what is meant by equilibrium constant? Equilibrium constant is the ratio of the product of the active masses of the products to the product of active masses of the reactant, and it is denoted by Kc as you are seeing on the screen. Next is about its units. So its units solely depend upon the expression. The last SLO of this chapter says that state the necessary condition for equilibrium and the way that equilibrium can be recognized. So there are five conditions for equilibrium. First of all, the container should be closed. Secondly, constant concentrations should be present. Next, there would be no change in the catalyst. There should be constant volume and constant pressure. So this is the end of discussion of the SLOs of this chapter. Please subscribe to the channel to get the notification about the next video, which will be a complete detail of each and every topic of this chapter. Thank you.